great. It's the quantum origin of skin cancer on the Royal Society.
Cancer. So this is a man. He's lying in the park. He's obviously exposed to sunlight, and we're going to focus in on his hand. We zoom in a little bit. You can see a close-up of his hand. We move into the skin and the keratin, which is the proteins that make up the skin. We go a little bit deeper. Eventually you'll get to a cell. And we're made up of millions and millions of cells. We then get through to chromosomes, and these are essentially the units that DNA is packaged into in our cells. This is a single chromosome, and you can start to see the DNA strands within this complex structure. And eventually we get to the DNA strand. So we've zoomed into this man's hand. He's been exposed to UV light, and it turns out, and this is just one of the types of DNA damage that can be induced by UV, is that thymines are adjacent to one another. In the energy of UV light can cause them to dimerize. So this looks pretty innocuous, this slight change, but this changes the coding properties of the DNA. If you can't repair this correctly, this can lead to mutation, and of course mutations lead to cancer. And this is very clearly illustrated by a rare disorder called xeroderma.
So basically the photon, if it hits the hydrogen specifically, I think it causes the hydrogen bond to form between thymine. And just imagine all the photons you get and how unlucky you are. But I guess really cancer is caused when you don't have a tan yet, so the melatonin hasn't centered in the middle of the cell, and I guess the chromosomes hide behind the melatonin to protect themselves against these mutations, because I guess melatonin absorbs the energy of the sun better than clearly DNA does. That's basically the quantum origin of skin cancer.